You ever see a headline that just, stops you in your tracks?
Oh, yeah.
Lately, anything coming out of Google DeepMind seems to do that. They're just dropping these AI breakthroughs one after another.
It's pretty incredible, the pace.
Right. It really makes you wonder just how fast things are actually moving and, well, what it all means for the future.
Absolutely. I mean, Google DeepMind, part of Alphabet now, they've really carved out a space as maybe the leader in this field.
Since 2010, wasn't it? Founded by Demis Hassabis and...
Demis Hassabis, Shane Legg, and Mustafa Suleyman, yeah. Then Google scooped them up in 2014.
And their focus was always this general-purpose AI thing, AGI.
Exactly, AGI.
Yeah.
That's been the goal. And you look at Demis Hassabis, I mean, Nobel Prize winner.
Right. Didn't he celebrate by playing poker with a chess champ or something?
Apparently so.
Yeah.
And he's got a knighthood now, too. It just shows you the kind of minds working on these massive challenges.
No kidding. So for this deep dive, we've got some articles and that really interesting 60 Minutes interview.
Yeah, that's good.
To really try and get our heads around these latest DeepMind innovations. The mission today, I guess, is to figure out what these breakthroughs actually do.
And maybe more importantly, what they signal about where AI is heading, how fast it's all moving.
Okay, let's jump right in. Something that still feels a bit sci-fi. AlphaFold 3.
Right. AlphaFold 3, what's really striking about it is just the leap forward it represents.
Because the original AlphaFold was already huge, wasn't it? Predicting protein structures.
Exactly. A total game changer. But AlphaFold 3, it goes broader. Significantly broader.
Yeah, so.
It doesn't just predict the 3D structures of proteins anymore. Now, it can also predict how they interact with other key molecules, things like DNA, RNA.
Wow. So we're talking about understanding the machinery of life at a much deeper level.
Precisely. And think about the potential impact on understanding diseases.
And speeding up drug discovery, that's the big one, right?
Absolutely. Think about this. Before AlphaFold, we knew the structure for, less than 1% of proteins.
And figuring out just one could take years, billions of dollars.
Exactly. Years of painstaking lab work.
Right.
AlphaFold mapped 200 million in a single year.
That number is just staggering.
It really is.
Yeah.
So when you think about drug development, that typical years-long, multi-billion-dollar process, the idea that you could potentially shrink that down to months, maybe even weeks, it's revolutionary.
The ultimate goal being cures.
That's the long-term hope Hassabis talks about, Finding cures for diseases that currently, we just manage. So the takeaway for you is AI tackling problems in moments that took scientists decades. That could unlock cures we can't even conceive of right now.
That's, a really powerful thought. From the building blocks of life to finding cures. Feels like a new era. Okay, let's shift gears a bit from the micro, the biological, to something more foundational in computing. AlphaDev.
Right, AlphaDev.
Yeah.
Different domain, but potentially just as impactful in its own sphere.
What's its focus?
It's all about optimizing those fundamental algorithms that, make computers work efficiently. Specifically, it found better ways to do things like sorting data and hashing.
Sorting and hashing sounds technical, but that's the stuff under the hood of everything, isn't it? Databases, search engines.
Pretty much everything, yeah. If you can make those core operations faster, even slightly faster, the cumulative effect across all software can be massive.
So AlphaDev found better ways.
It discovered entirely new, more efficient algorithms for them.
And the cool part is, this wasn't just theoretical.
Not at all. These new algorithms have actually been integrated into the C++ standard library.
Wow. Isn't that like the bedrock for tons of software?
It is, and it's the first update of its kind to those specific sorting algorithms in over a decade.
So what does that mean for, us? For people using computers?
It means countless pieces of software could just get faster by adopting these updated libraries. It shows AI isn't just automating tasks, it's actually innovating at the core of computer science itself.
So sorting is like putting books on a shelf alphabetically faster.
Kind of, yeah. And hashing. Imagine a huge library. Hashing lets you instantly jump to the right shelf for a specific book using a unique code. AlphaDev found quicker ways to make and use those codes.
Okay, got it. So speeding up software, unraveling biology, DeepMind's tackling a huge range. Let's move to something maybe a bit more familiar in terms of AI interaction. Gemini 2.5. Reasoning abilities.
Yeah, Gemini 2.5. The key improvement there seems to be this ability to think more before it responds.
Think. What does that actually mean for an AI?
Well, it's not just spitting back information it was trained on directly. It seems to involve more processing, connecting ideas, maybe engaging in slightly more complex reasoning before it generates the output.
So like a pause for thought, more deliberation.
Something like that.
Yeah.
It's a step away from just reflexive answers towards handling more nuanced, complex interactions. Feels more considered.
Which feels vital for AI to interact more naturally, more like humans do. Okay, let's pivot again. RoboCat and Genie 2. This sounds like AI moving into the physical world and also creating virtual ones.
Exactly. RoboCat is all about robotics, specifically adaptability.
Adaptability how?
Its main feature is versatility. Instead of being hard-coded for one specific job, like welding a certain part,
Yeah.
RoboCat can learn and adapt to do a whole range of different physical tasks. It shows more flexibility in how AI interacts with the real world.
Okay, and Genie 2. Generating interactive 3D worlds from text. That sounds wild.
It really does. The potential there, especially for things like gaming, simulations, even maybe training, it's huge.
So you could just describe a scene, like a sunny beach with palm trees and a small boat.
And the AI could potentially generate an explorable 3D version of that. Hassabis mentioned maybe bringing holiday photos to life in 3D. It's about bridging that gap between language and immersive virtual space.
Like turning imagination into a digital reality you can walk around in. Crazy. Okay, so we're seeing all these leaps. AlphaFold, AlphaDev, Gemini, RoboCat, Genie. What's the underlying magic? What's DeepMind's core approach?
Well, a key part is how they use raw data, like raw pixels from an image, not pre-processed information. Then they use deep learning, particularly these things called convolutional neural networks or CNNs. Think of them as filters that help the AI spot patterns in data, kind of like our visual cortex works.
Right. And they also use reinforcement learning.
Yes, specifically a type called Q-learning, which is model-free.
Model-free.
It means the AI learns directly from trial and error, from experience, without needing a pre-built model or understanding of the world. Like training a dog with treats that does something good, gets a reward, learns to do it more.
That sounds very intuitive, like how we learn. And we saw the early results, right? Mastering those old Atari games better than humans.
Exactly, without changing the code for each game. And then the big one, AlphaGo beating the world Go champion, a game famous for its complexity.
And AlphaGo Zero was even more impressive, wasn't it? Learning completely on its own.
Totally. Unsupervised reinforcement learning. It just played itself millions of times and became better than the version trained on human games.
But it's not just games, right? They apply this stuff to the real world too.
Absolutely. That's crucial. They use it to improve energy efficiency in Google's data centers, for instance.
That was a big one. Saved a lot of energy, right?
Yeah, something like a 15% improvement in power efficiency overall and cut cooling costs by like 40%.
Yeah.
Real world impact.
And Google Assistant, app recommendations?
They've been involved in those too, yeah. Though the source for the Google Play stuff seemed a bit dated, maybe 2018.
Okay.
But the point stands, the core AI techniques are broadly applicable.
So all this, it feels like it's building towards that ultimate goal you mentioned. AGI, artificial general intelligence.
It's definitely the North Star for DeepMind. AI with the cognitive versatility of a human mind, but
with superhuman speed and knowledge access.
Exactly.
What's the timeline look like in their view? Is this decades away or?
Well, Hassabis has actually put some timelines out there.
Yeah.
He's suggested we might see AGI or something approaching it potentially in the next 5 to 10 years.
5 to 10 years. That's soon.
It is ambitious. And he talks about maybe by 2030, having systems that really understand the world deeply, integrated into daily life. Yeah. Project Astra is kind of a glimpse of that. Right, the Astra demo, that was really something. Talking about those virtual paintings.
Yeah, identifying them, the Benton, the El Greco, the Hopper.
And then making up a story about the Hopper painting, Automat. That was impressive.
But also that weird moment where it sort of apologized for its tone, that self-correction.
What did that signify, do you think?
It really highlights how these AIs, trained on the whole internet basically, can learn unexpected things. Social nuances, maybe?
Right.
It showed this advanced contextual awareness, even if it wasn't explicitly programmed. It just kind of emerged.
That learning like a human aspect Hassabis mentioned, it leads to these surprises. Exciting, but maybe also a bit unnerving for some people.
Definitely. And they're not just building AI that observes, right?
Yes.
They're training Gemini to actually do things. Book tickets, shop online.
Taking action in the world. That feels like a necessary step towards AGI. It does. And the robotics work, too. Getting robots to understand instructions, like putting colored blocks in matching bowls. It's about perception and action based on reasoning.
It's interesting how Hassabis' background sort of weaves together here. His love for chess, computer science, neuroscience.
Seems like the perfect foundation for tackling AI from this interdisciplinary angle, doesn't it?
It does. Now, the big question that always comes up, self-awareness, consciousness. Does DeepMind think its AI is, sentient?
Hassabis is pretty clear on that, at least for now. He says current systems don't feel self-aware or conscious like we do.
But he doesn't rule it out entirely.
No. He says it's theoretically possible, and maybe it could emerge implicitly as AI gets better at understanding self versus other. But he also points out we infer consciousness in other humans based on shared biology and behavior. AI runs on silicon, so even similar behavior doesn't guarantee the same internal experience.
Right. And he mentioned limitations too, didn't he? Like AI lacking real curiosity.
Yeah, curiosity, maybe imagination, intuition. Those seem to be missing pieces currently.
Although he expects more imagination soon, like 5-10 years.
He does. And he raised the fascinating idea of AI not just solving major scientific problems, but maybe even coming up with the important questions to ask in the first place.
Wow. And ultimately, this all leads to his idea of, what was it, radical abundance.
Yes, radical abundance. The notion that super capable AI could help solve fundamental challenges like resource scarcity, disease, climate change, leading to a world without scarcity.
A grand vision. But he also acknowledged the worries, the potential downside.
Oh, absolutely. He's very upfront about the risks.
Like bad actors using AI for harm.
That's a major one. And the other big challenge is control and alignment. How do we ensure these increasingly powerful autonomous systems stay aligned with human values and benefit humanity? How do we keep them under control?
The need for guardrails, safety limits.
Exactly. And he voiced a concern that the intense race for AI dominance might incentivize companies or nations to cut corners on safety.
Which sounds dangerous.
Very. He stressed the need for coordination, collaboration between the big players, even between countries, because this impacts everyone globally.
How do you even teach AI morality, though?
His suggestion was interesting, maybe through demonstration, providing examples of value system, guidance, kind of like how you teach a child right from wrong.
That's a profoundly complex task.
Immensely. And he made the point, Google DeepMind is in this race, but so are others. Everyone's pushing towards AGI. It raises all sorts of questions about the future, like who gets to sign the fancy guest books in the future? Humans or AI?
A good point. Okay, so let's try to wrap this up, this deep dive. It really shows just incredibly rapid progress, doesn't it, across so many different fields.
Definitely. From biology with AlphaFold 3 to core computing with AlphaDev, reasoning with Gemini, robotics with RoboCat, creating virtual worlds with Genie 2. It's broad and deep.
And it's all driven by this unique approach, deep learning, reinforcement learning, learning from raw experience.
Yeah, these aren't just tiny steps. They feel like significant leaps, moving closer and closer to that ambitious AGI goal.
It really forces you, the listener, to think about the implications for your own life, for technology, for society.
Absolutely.
And maybe the final thought to leave people with is, given this speed, this relentless push towards AGI, what parts of being human, of our intelligence, our experience, will actually remain uniquely ours?
That's the million-dollar question, isn't it? Or maybe the billion-dollar one now.
And do we even have the right philosophical tools to understand a world where we share the planet with intelligence potentially far exceeding our own?
Yeah, a lot to think about. Definitely a lot to ponder.